In the previous section, we developed a host VI on the RT target that communicates with the FPGA VI. By the end of this module, you will be able to develop a Windows VI on a PC that acts as a user interface and communicates with the host VI on the RT target. So we just finished talking about the real-time piece on this graphic, and in this section what we're going to talk about is the Windows piece. So what we're going to talk about is, now that you have a host VI on your RT target, how do you communicate between that host VI and a Windows VI that's running on a Windows system that is going to allow us to have a user interface? So let's talk about developing a Windows VI. Some possible tasks that you would have your Windows VI handling is, one, it can be a user interface that's running on a Windows machine that your users can access and interact with. Also, you can send data and commands to your RT host from this Windows VI, so you can have some communication going back and forth. And another advantage of having a Windows VI is you can take advantage of Windows compatible functionality. So for example, you can use .NET, you can use databases like Microsoft Access, you can use enterprise applications that work on Windows. So there's a lot of stuff you can do there. A Windows computer is probably going to have a lot of hard drive space, so you can also create big log files there. You can also use data processing, because on a Windows computer you could probably have a lot of CPUs and memory and things like that. So once you have a Windows VI, how would you communicate between the Windows VI and the host VI that's sitting on your RT target? Well, you would have to use some sort of network communication. So the RT target is going to be there on the network, and you'll have to use different types of network communication protocols to communicate data between your Windows VI and your RT target. So now that you have network communication, you can have an RT VI and also a Windows VI running at the same time. You can communicate data between the two. You can transfer latest data. You can transfer buffer data. You can decide what pieces you want to put on your Windows VI and what pieces you want to put on your RT VI. One method you can use for network communication is using network published shared variables. And shared variables in general allow you to communicate between multiple processes, also between multiple VIs. And if you're using a network published shared variable, you can use it to communicate between multiple computers or devices over the network. So to create a shared variable, you would have to go to your Project Explorer window. And what you would do is you can right-click your target, you can go to New, and then Variable. So shared variables must reside inside a project library. So if you create a variable without a library, LabVIEW will automatically generate the library for you. So if you take a look at this screenshot here, you'll see that there is a library there called variables.lvlib. So if you've already created a library, you can add another variable to it by right-clicking the library, going to New, and selecting Variable. Notice that on the screenshot, there's already a stop variable and a temperature variable that are contained within that library. In this particular example, the shared variables are residing under your RT target. If you wanted to, you could also have the shared variables residing on your Windows computer, and in that case you would have to create them under the My Computer item. So once you've right-clicked and created new variable, what you'll get is a configuration window to configure your shared variable. So in this case, what we want to use the shared variable to communicate between our RT target and our Windows VI. Okay, so because of that, we need to set our variable type to network published. That way, we're going to be able to share data using that shared variable over the network. And real quick, I just want to bring your attention to this particular page on your shared variables properties window. So if you go to the RT FIFO category on the left, you'll be able to enable something called Enable RT FIFO. And what that does is it allows you to share data across the network without affecting the determinism of the RT VIs in which that shared variable resides. So for more information on that, you can take a look at the LabVIEW Real-Time 1 course or look at the LabVIEW Real-Time Help. So in these slides, we just described one of the network communication methods. Namely, we talked about shared variables over the network. But there are many other ways of transferring data over the network. So for example, there's TCP, there's UDP. We talked about network shared variables. You can do that with or without an RT FIFO, depending on what your application needs. And also you can use network streams, which is a good way of transferring buffered values over the network. So all of these methods are covered in both the LabVIEW Real-Time Help and also in the LabVIEW Real-Time 1 course. So when you're done creating and testing your RT host VI, you need to prepare it for your final application when you're done. So for the final RT application, again, you don't want to use this front panel communication that we use for debugging and getting started. Instead, we want to compile the RTVI into what's called a startup exe or startup VI. So for more information on this, either refer to the help or you can look at the real-time 1 and 2 courses. So at this point, to get more experience with using an FPGA VI with the RT VI with the Windows VI, you can do exercise 11.2. So this is a great exercise where we take those 3 pieces together. We're going to have a FPGA VI that gets temperature, and then we're going to send that information and communicate between FPGA VI and the RT host VI. And then once we're done with that, we're going to add a Windows VI piece and have the RT and Windows VI communicate with each other as well. So to see more on that, refer to the solution module.